Silica gel is a granular, vitreous, porous form of silicon dioxide made synthetically from sodium silicate. Silica gel is tough and hard. It is more solid than common household gels like gelatin or agar. It is a naturally occurring mineral that is purified and processed into either granular or beaded form. As a desiccant, it has an average pore size of 2.4 nanometers and has a strong affinity for water molecules. Silica gel is most commonly encountered in everyday life as beads in a small paper packet. In this form, it is used as a desiccant to control local humidity to avoid spoilage or degradation of some goods. Because silica gel can have added chemical indicators and absorbs moisture very well, silica gel packets usually bear warnings for the user not to eat the contents. History: silica gel was in existence as early as the 1640s as a scientific curiosity. It was used in World War I for the adsorption of vapors and gases in gas mask canisters. The synthetic route for producing silica gel was patented by chemistry professor Walter A. Patrick at Johns Hopkins University in 1918. In World War II, silica gel was indispensable in the war effort for keeping penicillin dry, protecting military equipment from moisture damage, as a fluid cracking catalyst for the production of high-octane gasoline, and as a catalyst support for the manufacture of butadiene from ethanol, feedstock for the synthetic rubber program. Types: Type A, clear pellets, approximate pore diameter, 2.5 nanometers, drying and moisture-proof properties, can be used as catalyst carriers, adsorbents, separators and variable pressure adsorbent. Type B, translucent white pellets, pore diameter, 4.5 to 7.0 nanometers, liquid adsorbents, dryer and perfume carriers, also may be used as catalyst carriers, catalytor. Type C, translucent, micropored structure, raw material for preparation of silica gel catalytor. Additionally dried and screened, it forms macropored silica gel which is used as dryer, adsorbent and catalyst carrier. Silica alumina gel, light yellow, chemically stable, flame-resistant, insoluble except in alkali or hydrofluoric acid. Superficial polarity, thermal stability, performance greater than fine-pored silica gel. Stabilizing silica gel, non-crystalline microporous solid powder, non-toxic, flame-resisting, used in brewery of grains for beer to improve taste, clearness, color and foam, removal of non-microorganism impurities. Properties: silica gel's high surface area allows it to absorb water readily, making it useful as a desiccant. Silica gel is often described as absorbing moisture, which may be appropriate when the gel's microscopic structure is ignored, as in silica gel packs or other products. However, chemically, material silica gel removes moisture by adsorption onto the surface of its numerous pores rather than by absorption into the bulk of the gel. Regeneration: once saturated with water, the gel can be regenerated by heating it to 120 °C for 2 hours. Some types of silica gel will pop when exposed to enough water. This is caused by breakage of the silica spheres when contacting the water. Preparation: a solution of sodium silicate is acidified to produce a gelatinous precipitate that was washed, then dehydrated to produce colorless silica gel. When a visible indication of the moisture content of the silica gel is required, ammonium tetrachlorocobaltate, 2,2-CoCl4 or cobalt chloride CoCl2 is added. This will cause the gel to be blue when dry and pink when hydrated. An alternative indicator is methyl violet, which is orange when dry and green when hydrated. Applications: desiccant. In many items, moisture encourages the growth of mold and spoilage. Condensation may also damage other items like electronics and may speed the decomposition of chemicals, such as those in vitamin pills. Through the inclusion of silica gel packets, these items can be preserved longer. Silica gel may also be used to keep the relative humidity inside a high-frequency radio or satellite transmission system waveguide as low as possible. Excessive moisture buildup within a waveguide can cause arcing inside the waveguide itself, damaging the power amplifier feeding it. Also, the beads of water that form and condense inside the waveguide change the characteristic impedance and frequency, degrading the signal. It is common for a small compressed air system to be employed to circulate the air inside the waveguide over a jar of silica gel. Silica gel is also used to dry the air in industrial compressed air systems. Air from the compressor discharge flows through a bed of silica gel beads. The silica gel absorbs moisture from the air, preventing damage at the point of use of the compressed air due to condensation or moisture. The same system is used to dry the compressed air on railway locomotives, where condensation and ice in the brake air pipes can lead to brake failure. Silica gel is sometimes used as a preservation tool to control relative humidity in museum and library exhibitions and storage. Other applications include diagnostic test strips, inhalation devices, syringes, drug test kits and hospital sanitation kits. Chemistry. In chemistry, silica gel is used in chromatography as a stationary phase. In column chromatography, the stationary phase is most often composed of silica gel particles of 40 Euro 63 I1/4 m. Different particle sizes are used for achieving a desired separation of certain molecular sizes. In this application, due to silica gel's polarity, non-polar components tend to elute before more polar ones, hence the name normal phase chromatography. However, when hydrophobic groups are attached to the silica gel, then polar components elute first and the method is referred to as reverse phase chromatography. Silica gel is also applied to aluminium, glass, or plastic sheets for thin layer chromatography. The hydroxy groups on the surface of silica can be functionalized to afford specialty silica gels that exhibit unique stationary phase parameters. These so-called functionalized silica gels are also used in organic synthesis and purification as insoluble reagents and scavengers. Chelating groups have also been covalently bound to silica gel. These materials have the ability to remove metal ions selectively from aqueous media. Chelating groups can be covalently bound to polyamines that have been grafted onto a silica gel surface, producing a material of greater mechanical integrity. Silica gel is also combined with alkali metals to form a MSG reducing agent. Silica gel is not expected to biodegrade in either water or soil. Cat litter. Silica gel is also used as cat litter, by itself or in combination with more traditional materials, such as clays including bentonite. It is trackless and virtually odorless. Purchasing silica in the form of cat litter can be an easy and cost-effective way for retail consumers to purchase silica gel for use in other applications, such as maintaining the desired relative humidity in humidors, keeping tools or other materials rust-free in damp environments or long-term storage, and preserving dried food. Food additive. Silica gel, also referred to as silica aerogel or hydrated silica, has FDA GRAS status, meaning it can be added to food products without needing approval. Silica is allowed to be added to food in the U.S. at up to 2% as permitted under 21 CFR 172.480. In the EU it can be in up to 5% concentrations. Listed uses include, anti-caking agent, defoaming agent, stabilizer, adsorbent, carrier, conditioning agent, chill-proofing agent, filter aid, emulsifying agent, viscosity control agent, and anti-settling agent. Hazards. Silica gel is non-toxic, non-flammable, and non-reactive and stable with ordinary usage. It will react with hydrogen fluoride, fluorine, oxygen difluoride, chlorine trifluoride, strong acids, strong bases, and oxidizers. Silica gel is irritating to the respiratory tract and may cause irritation of the digestive tract, and dust from the beads may cause irritation to the skin and eyes, so precautions should be taken. Crystalline silica dust can cause silicosis, but synthetic amorphous silica gel is indurated, and so does not cause silicosis. Humidity indicator. Silica gel may be doped with a moisture indicator that gradually changes its color when it transitions from the anhydrous state to the hydrated state. Common indicators are cobalt, chloride and methyl violet. Cobalt chloride is deep blue when dry and pink when wet. It is toxic and carcinogenic, and was reclassified by the European Union in July 2000 as a toxic material. Methyl violet can be formulated to change from orange to green, or orange to colorless. It is also toxic and potentially carcinogenic, but is safe enough to have medicinal uses. References. External links. Record in the Household Products Database of NLM, UK Materials Safety Data Sheet, Silica Gel with Moisture Indicator, Instructions for Use, Detailed Use and Redrying Info, Silica Gel Dehumidifier FAQs, Helpful information on rechargeable silica packs for home usage, silica-bound reagents, information on development and tables illustrating reactivity, silica-bound scavengers, general notes and tables that summarize scavenging capacity, Education Center.